Alright guys, so Happy New Year. We have gone into 2021 by now. Hope things are going well. This is January the 4th through the 8th, so please make sure that you do have lesson 26 in front of you. Alright. The great news is this lesson should not take us long. The not so great news is it is strictly a proof lesson. So we're going to be writing proofs. I'm going to do my best to work through these with you and try to explain them the best that I can, knowing that we are not in person. It's going to be a little difficult, but we're going to get through it. So let's go ahead. We are looking at triangle congruency proofs. By now we have talked about several different ways that we can prove our triangles congruent. Some of the examples: angle, side, angle, side, the HL theorem. So we're going to kind of put it all together. So our outcome for today, our learning target is students complete proofs requiring a synthesis of skills learned in the last 4 lessons. In other words, we're putting the last 4 lessons together and we are going to construct some proofs. Alright, so let's go ahead and get started with this. Remember, with any proof, go ahead and look at what you already know and then go from there. Alright, so let's look at this one. In number 1, we are given that AB is perpendicular to BC. Now, we'll think about what that means about perpendicular lines here in a moment. We are given that BC is perpendicular to DC. We are given that DB bisects angle ABC, this angle here, and AC bisects angle DCB, this angle here. We are also given that EB is equal to EC. Okay, so really right now there's not a whole lot we can mark, but we can go ahead and mark that we know that EB is congruent to EC. Alright, so now let's kind of break this up. I'm going to break our givens up for a moment, and we're actually going to have 2 steps
Lily Johnson to the office, Lily Johnson
that are given statements. Okay? So we're going to deal with our perpendicular lines first. Alright? And the only reason I'm breaking these up is because I want to deal with them separate, because each one of our given statements gives us a lot of information. So we're going to make step number 1, segment AB is perpendicular to segment BC, and segment BC is perpendicular to segment DC. Alright, and that is given. Now, this is where we need to think about what we know about perpendicular. What does it mean to be perpendicular? If I have 2 segments that are perpendicular to each other, we know that the angle they form is a 90-degree angle. So I know that angle ABC is equal to 90 degrees. And I also know that the measure of angle DCB is equal to 90 degrees. Why do I know that? Because it is simply the definition of perpendicular lines. Now, I can go ahead and put the square corner in there. That will kind of help me know that those are 90-degree angles. Alright? So now, what do I know about the measure of those 2 angles? Well, I know that those 2 angles are actually equal. Alright, so the measure of angle ABC is equal to the measure of angle DCB, and that is by the transitive property. We've already proven that they both equal 90 degrees, now we're just proving that they're equal. Okay? Alright, now that's about all we can do with our perpendicular lines right now. So let's go to our second given statement. Our second given statement is that DB bisects angle ABC and segment AC bisects angle DCB. Alright, and that is given. Now, what do we know about bisectors? Bisectors mean that they divide something into two equal parts. So if if DB is a bisector of this angle, and if AC is a bisector of this angle, we know that it is divided into two equal parts. Each angle is divided into two equal parts. Alright, so if we already know, we've already proven these are 90-degree angles, what is half of 90 degrees? That would be 45. So I can now say that the measure of angle ABE is equal to 45 degrees. Alright. And then if I know that AC bisects this angle, then I know the measure of angle DCE equals 45 degrees. How do I know that? That is simply the definition of an angle bisector. Alright, so now I know that this angle is equal to this angle. Now, let's go back and look. We're trying to prove BEA is equal to CED. So we're trying to prove these two triangles equal here. Alright. Now, right now we have a side and we have an angle of each triangle. So we've got to either figure out another side, another angle. We've got to figure something out. Alright, let's look at our third given step. EB is equal to EC, and that is given. Okay. Now, we're trying to prove, we're not even worried about this part down here. We're just looking at these two triangles here. Guys, look at those two triangles. They share something in common. They share an angle. Angle E in both triangles. So I can say that the measure of angle AEB is equal to the measure of angle DEC because vertical angles are equal in measure. Alright, we know that vertical angles are equal. So we've now proven another angle. So do I have enough information to prove this triangle congruent? I do. Triangle BEA is congruent to triangle CED. Why? By angle, side, angle. Okay. Let's look at number 2. Number 2, once again, we're going to kind of split up our given information just so we can look at it. This one's a little bit shorter than the last one. So I know that BF is perpendicular to AC. I know that CE is perpendicular to AB. I know that AE is equal to AF. And I want to prove that triangle ACE, this triangle here, is congruent to triangle ABF, this triangle here. Alright? So, here's what you can do. If it helps you to visualize it a little bit better, you can split it up. So I have ABF, and I'm looking at AEC. So ACE and ABF. I want to prove those two triangles are congruent. Alright, so let's start with our first given statement. We're going to split this up into BF is perpendicular to AC and CE is perpendicular to AB. That is given. So since we know about perpendicular, then let's see what we can use there. We know perpendicular means that it forms right angles. So let's see if we can figure out our right angles here. Alright, so if BF is perpendicular to AC, then I know that angle BFA is 90 degrees. So the measure of angle BFA is 90 degrees. Alright, so I can go ahead and mark that. If I know that CE is perpendicular to AB, then I know that angle AEC is equal to 90 degrees. So I know this is a 90-degree angle. And that is simply the definition of perpendicular lines. I'm going to abbreviate here. Alright? Since we know that they are both 90 degrees, I don't necessarily have to worry about proving they are equal right now. We're just going to go on to our next given statement that AE is equal to AF. So AE is equal to AF. That is given. Now, here's where I can look at this. Right now I have an angle and I have a side. I need to figure out how else how we can go about figuring this out. Looking at this, guys, it's very simple. Technically, I guess we need to probably go back and add a fourth step. That the measure of angle BFA is equal to the measure of angle AEC. And that is the transitive property, because we know that both of them are equal. So now we have an angle and we have a side. Guys, if you look at your two triangles, you notice they share something. They share, what? Do they share sides? They don't. Do they share angles? They both have angle A in them. So I know that the measure of angle A is equal to the measure of angle A. It's the same. That would be the reflexive property. Okay? So I've now proven that angle A is equal to the measure of angle A. Now, do I have enough information to prove that my triangles are congruent? I do. Triangle ACE is congruent to triangle ABF by angle, side, angle. So I have angle, side, angle. Okay? Hopefully these are getting a little simpler for you. I know it's still kind of hard, but we'll get there. All right, so we are given that xj is equal to yk. We are given that px is equal to py. We're given angle zxj, this angle here, is equal to angle zyk, this angle here. And they want us to prove that jy is equal to kx. Alright, so let's go ahead, and this one we're just going to kind of lump all of our givens together because there's not a whole lot that I can take out of the given. It's just simply statements. So xj is equal to yk. So I'm going to go ahead and mark that. xj is equal to yk. Px is equal to py. angle ZXJ is equal to angle ZYK, and that's all given. So ZYK, so this angle is equal to this angle. Alright, and our whole goal is to figure out that this long side is equal to that long side. Okay. So, looking at this, if I know that this segment is equal to each other and this segment is equal to each other, what do I know about the whole sides? Because if I'm trying to figure out that JY is equal to KX, then I'm probably going to have to deal with the bigger triangles. Okay, I'm probably not going to look at the two little small triangles right now. I'm going to have to deal with proving something about these big triangles. So, I know that this portion is equal to this portion, and this portion is equal to this portion. So, let's just say that this was 5 and this was 6. So, if this is 5 and 6, this side would be 11. That means this 5 and 6, that means that side would be 11. So I can now prove that in my second step that JP is equal to KP, and that is simply segment addition. Alright, that means I'm simply just putting together what I know. Alright, so I'm going to go ahead and separate my two triangles so that I can kind of see what's going on here. So I have JPY, and I'm not drawing them perfect, but that's okay, and KXP. Okay, so now I know that JP is equal to KP. Alright, I know that right now. Alright, now, going back to my diagram here, what do I know? Now I need to still look at my two small triangles. Notice I have vertical angles here. Alright, and this is going to help me because you'll see why in just a moment. I have angle, the measure of angle JZX is equal to the measure of angle KZY. Why are those two angles equal? Because they are vertical angles, and vertical angles are equal in measure. Okay? So, I have vertical angles. Guys, look at this. Can I prove that my two triangles are congruent? That my two triangles are congruent? I can by angle, angle, side. Look, I have angle, angle, side, angle, angle, side. Alright, so I can prove these two small triangles are congruent. Triangle JXZ is congruent to triangle KYZ by angle, angle, side. The reason I'm doing this is because since I know they are congruent triangles, then I know that every part of these two triangles are equal. Alright, so what does that now tell me about angle J and angle K? Angle J is congruent to angle K by CP/CTC. Congruent parts of congruent triangles are congruent. So now look what I've done. I have now added an angle to my big triangles. Alright? Alright, now, looking at this, guys, what do I see they share? I see that they share angle P. So because angle P is the same in both triangles, angle P is congruent to angle P by the reflexive property. Can I prove my two triangles congruent now? I can. So triangle PJY is congruent to triangle PKX because of angle side angle. Alright, so now, since I have proven these two triangles congruent, I know that every part of those triangles are congruent. So I can prove that JY is congruent to KX, alright, because of CPCTC, congruent parts of congruent triangles are congruent, but it is still not exactly like what I have here in my prove. Alright, so now I've got to go one more step and say JY is equal to KX because of the definition of congruent segments. Okay. Definition of congruent segments. Alright, number 4. So number 4, I'm given JK is equal to JL. I'm given JK is parallel to XY. And they want us to prove that XY is equal to XL. Alright, so we're going to split our given up for just a moment. We'll go with JK is equal to JL. Alright, and that is given. So JK is congruent to JL. Alright. Now, take out this middle segment here for just a moment, and what kind of triangle do I have? I have an isosceles triangle. So because I have an isosceles triangle, what do I know about the angles of an isosceles triangle? I know that the base angles are equal. So, the measure of angle K is equal to the measure of angle L. Because the base angles of an isosceles triangle are equal. Okay? So now look at this. I've got congruent angles now. Okay? Now I'm going to address my next section of given information that JK is parallel to segment XY. That is given. Alright, we know when they're parallel, that means they run side by side, they're never going to touch. But that also probably means that there is a transversal somewhere. So if I know that JK and XY are parallel, then this could be a transversal, this could be a transversal. So we kind of need to look at that. So I'm trying to figure out that XY is equal to XL. Alright? I'm trying to figure out these two sides here. So I'm kind of looking at that small triangle. So I'm probably going to try to figure out something about this angle here. Because think about this. If I can prove this angle is equal to this angle in some way, then I have base angles that are equal, so that means that the sides would be equal because they'd be an isosceles triangle. So I kind of have to, this is the type of thing that you kind of look for the end result and then work backwards. Alright, so with this being parallel lines, I can look at the measure of angle K and the measure of X, Y, L as being equal, because if you look at this, if these are our parallel lines and this is our transversal, these two angles would be corresponding angles. Alright, so I can say the measure of angle K is equal to the measure of angle XYL, because they're corresponding angles. Oops, I spelled that. Okay? So I have corresponding angles here. So if that's congruent to that, then what do I know about this here? Alright? So if I know they're equal, then I can also prove that the measure of angle XYL is equal to the measure of angle L by the transitive property. And since I've proven these two angles congruent, now I can say that XY, well, I'll tell you what, let's make one more, no, we can just go ahead and jump to XY is equal to XL. Because if two angles of a triangle are congruent, then the sides opposite their angles are equal in length. So since I have proven those two angles congruent, then I know the two sides opposites are going to be equal in length. Alright, we have two more, guys. Number 5. Alright, we're given that the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is equal to the measure of angle 4. And they want us to prove that AC is equal to BD. Alright, so let's go ahead and look at this. We'll work with splitting our angles up, our given information up first. Angle 1 is congruent to angle 2, and that is given. Okay? So angle 1 is congruent to angle 2. Since I know that, there's a couple things I can figure out here. But we just dealt with this in the last one. I'm just going to kind of look at this small triangle. Since I have two angles that are equal, then what do I know about the sides of this triangle? I know they are equal also. So I can say that BE is congruent to CE. Alright? When two angles over a triangle are congruent, it's an isosceles triangle. Okay? So I know I have an isosceles triangle here. Alright? There's not much more I can go there, so let's go ahead and look at our second piece of given information. Angle 3 is equal to angle 4. That is given. We'll go ahead and mark that. Angle 3 is equal to angle 4. Alright. Now, let's go ahead and look at this. I do have a vertical angle here, so we can look at this as a vertical angle. I do have a vertical angle here, AEB and DEC. So my fourth step, angle AEB is congruent to angle DEC because they are vertical angles. Alright, so we can do that. Alright, remember our goal is AC is equal to BD. So we got that long one. Alright, now, let's look at this for just a second. Can I prove any of my triangles congruent yet? I actually can. I think. Let's kind of split these up here. So A, B, C. And D, B, C. Alright, so let's look at this. I know these two angles are equal. ABC and DCB, because these two parts are equal and these two parts are equal. So I already know that those two angles are equal. Alright. I need to look at proving these two triangles are congruent. Notice they share a side. Alright, so I can go ahead and say that BC is congruent to BC. Reflexive property. It's the same in both triangles. Okay? Let's see what else I need to figure out. So I've got an angle and I've got a side. So I need to figure out another way that I can prove congruence here. These angles are the same, and these angles are the same. So I already have it actually. I just didn't have it marked correctly. I can actually go ahead and prove these triangles are congruent. So triangle ABC is congruent to triangle DCB. Why? Because of angle, side, angle. Okay? Now since these are congruent triangles, I now can prove that angle A is congruent to angle D. Alright? So I'm going to prove that this angle is congruent to this angle because of corresponding or congruent parts of congruent triangles. Corresponding parts of congruent triangles are congruent. I'll get it out here in just a moment. Alright? Now, I can prove my triangle congruence again if I need to. But since I've already proven my triangle congruent, what do I know about AC and DB? AC is congruent to BD because corresponding parts of congruent triangles are congruent. My triangles are congruent, so therefore, because they are congruent triangles, every part is congruent. So I've proven my sides to be congruent. Sorry, my paper keeps sliding out of the screen. Alright, last one. Alright, the measure of angle 1 is equal to the measure of angle 2. The measure of angle 3 is equal to the measure of angle 4. And AB is equal to AC. And there's two parts they want us to prove. They want us to prove that triangle ABD, this big triangle here, is congruent to triangle ACD, this big triangle here. And they want us to prove the measure of angle 5 is equal to the measure of angle 6. Okay, so let's just kind of go ahead and do this. We're just gonna deal with our given information first. We'll deal with the measure of angle 1 is equal to the measure of angle 2, and the measure of angle 3 is equal to the measure of angle 4. That is given. Okay, so 1 is equal to 2 and 3 is equal to 4. So what do I know about that then? So if 1 is, let's just say that 1 is 10, that means 2 is 10. If 3 is 15, that means 4 is 15. So what do I know about angle 1 and angle 3, and angle 2 and angle 4? I know that the measure of angle 1 plus the measure of angle 3 would give me angle DAB. And I know that the measure of angle 2 plus the measure of angle 4 would give me the measure of angle CAD. Okay? And that is simply angle addition postulate. Alright? So now, since I know that these two statements are true, then what I can do is I can substitute. So I can now say that the measure of angle DAB is equal to the measure of angle CAD. Alright, so now I know that this angle is equal to this angle. Alright, by angle addition, or by substitution property of equality. Alright, now, let's look at this. Guys, my two triangles share a side. They share AD. So AD is equal to AD by the reflexive property. Alright, so I'm going to, at this point in time, I'm going to separate my triangles here, just so I can kind of visualize what's happening. So I have BDA and ADC. So I know that DAB is equal to DAC. I know that DA is equal to DA. Alright, so I'm closer to proving my two triangles congruent. Alright, so let's look at this. Can I prove my two triangles congruent just yet? Well, look guys, I share an angle here. Alright, we share an angle. We share angle D. But can I prove that congruent? No. But look at my given information, and we didn't write this down. We'll write this down. AB is equal to AC. AB is equal to AC. Now I can prove my triangle is congruent. Triangle ABD is congruent to triangle ACD by side angle side. Alright. Now, they want us to prove the measure of angle 5 is equal to the measure of angle 6. Let's see what we can do there. Alright. I know that these two angles are going to be equal. Angle ABD, or I'm sorry, BDA, and angle, just completely lost my thing. I just lost my thought, guys. Give me just a second. Okay, let's look at this. We want to prove these two triangles, we're trying to prove angle 5, which is in the middle here. So here is angle 5. So I need to kind of draw this here. Here's angle 5. And here's angle 6. So now they want us to prove these two angles are congruent. Alright? With that being said, this is X and this is Y. Alright? So I know that angle DXA I'm skipping a step. BDA and YDA. Okay. So I can prove, here's where my step that I'm missing. BDA, this angle here, is congruent to AYD. Alright? So the measure of angle BDA is congruent to the measure of angle YDA because of corresponding parts of congruent triangles. Okay? So now I know that these two angles are congruent. Alright? Now with that being said, look at what I can prove. I can prove, cut these little pieces off here. Because angle 5 and angle 6 are actually in their own little triangles. So I can prove these triangles congruent. I can prove that triangle DXA is congruent to triangle DYA by angle side angle. And since that's the case, the measure of angle 5 has to be equal to the measure of angle 6 because of corresponding parts of congruent triangles are congruent. Okay? Guys, like I said, I know these are hard because they're even hard for me. My brain gets tangled and thinking about what's going on, and I try to go too many steps at a time. Try, practice, do your best. Hopefully we'll be back in the school in person soon. Guys, have a great week.